In this video, we're going to talk about how we can use Azure to create serverless logic using the Azure Functions. Now, the serverless logic is the idea of having a server or a computer that does something, but we don't actually have a computer. It's just simply a process that we can perform without having to build the actual infrastructure to support that. In order to do that, we're going to be using the Microsoft Learn sandboxes in order to walk through one of their labs. So here I am. I'm already logged into the Microsoft Learn sandboxes up here at docs.microsoft.com/enuslearn, and then I'm going to click Browse All Learning Options. As we can see, there are over 1,800 different labs that I can work on. The one I'm going to be looking for, it talks about Azure Functions. So I'm going to go ahead and I'm going to type in serverless logic. And it's this guy right here. Create serverless logic with Azure Functions. That's the one that I want to start with. So we'll go ahead and start with the introduction. It talks about what exactly is serverless logic. Let's see. First off, you work for an escalator company. We are investing in IoT or Internet of Things technology, and we want to be able to monitor our escalators remotely. Not only do we want to monitor our escalators, but we want to see a dashboard that tells us how things are working and then also alert us if any problems occur. Specifically, in this case, we are monitoring the temperature on some gears or various devices in our environment, and we want to get a red flag warning if things get too hot, or see green across the board when things are working fine. Now in this scenario, this is going to be a very, very introductory scenario, so we're not going to go super in-depth into it, but we're going to go enough in-depth to be able to see how this should be able to work. See, very quickly, learning objectives. Does serverless computing meet your need? We're then going to create our very first function and execute that function using some triggers. And then we'll also monitor that function to make sure it is working properly. All right, so the next page talks a little bit about whether serverless meets our needs. Basically, the idea is that this is a function as a service. Maybe I have a function that normally would require its own server. Now, that means that in order to support that server, I have to buy the server, which is anywhere from $50 up to several $1,000s. I then have to buy an operating system for it. I have to have somebody maintain that operating system, install Windows updates and so on, make sure the network is working, have a physical network port for it to plug into, have power, lots of different activities that have to go into place for that server to work before I can even use it for a function. But maybe I don't need a full-blown server. Maybe that server is only, or service is only happening a couple of times an hour, maybe every 5, 10, 15 minutes. Therefore, I don't need a full-blown server. I just need something that is capable of running a task for that period of time. That's where the function as a service comes in, sometimes referred to as a microservice. So Azure Functions works on a serverless application platform, allows you to perform commands without having the server yourself. Lots of benefits. Business logic code can be built into the cloud. For instance, one scenario might be HR every single day sends me a list for new employees. And that list is uploaded somewhere on the local file system or somewhere up in Azure for me to be able to see. And therefore I want to go ahead and automatically create new users in Active Directory based off of that list. So my business logic is to get a list from HR, create Active Directory users, and put them into whatever security groups are appropriate. I could write that as code and then have that happen automatically. Avoids over allocation of infrastructure. There we go. Not only does it avoid over allocation of infrastructure, but it also allows for quick and rapid expansion and then retraction of that infrastructure. Drawbacks, execution time. These may run a little bit slower than necessary. Now, in the scenario of getting a list of users to be able to create into Active Directory, that's perfectly fine. If it runs, say, at 7:45 every single day, and it says that it's going to take 5 minutes to run, well, that's perfectly acceptable. If, however, we're talking about a real life and death situation, say a 911 dispatch center, their milliseconds can count, and therefore we wouldn't want to have some sort of a serverless function as we would in other cases. Execution frequency, it talks about if you're going to be running this a whole lot, you may want something else. However, if we're talking, again, like once an hour, once a day kind of functions, it's not going to be that big of a problem. All right, well, let's go ahead and let's get started. So I've gone ahead and I've activated my sandbox, and this gives me an option for what kind of development language we want to do. I've used this before with JavaScript. This time I'm going to be doing it in PowerShell. It's just something I'm a little bit more familiar with PowerShell, and I hadn't been able to previously do it in PowerShell, so I'm really curious to see how well it works. Let's see, what is a function app? Choose a service plan, storage account requirements. There you go, on to creating the function app. It says to go ahead and sign into the Azure Portal. Before I go into this, I will mention these steps are a little out of date. The Azure Portal has been updated since these instructions have been created, so it will take a little bit of intelligent work on our part to be able to tie the missing pieces or the lost pieces together. All right, so I will go ahead and create a function app. First off, I'm in Azure. I can see, yep, I've got my app service plan. I don't think I want that. That was from something I'd previously done. And I don't want the storage account on. Storage account, delete. All right, so there you can see under all resources, I have my Cloud Shell, but the first step of the instruction says to go ahead and let's create the new function app. To do the new function app, I'm going to go up here where the little hamburger menu is. I'm going to select that, and I'm going to say create a resource. Under create resource, I can see here under popular, I do in fact have a function app as an option. If that does not show up under popular anymore, a function app is a type of compute, and therefore I can come over here under the marketplace and look under compute. Keep searching, and there's my function app. Worst case scenario, I choose see all and then choose the function app from there. All right, so function app. We start off with the subscription. Who is paying for this? In this case, because this is the Microsoft Learn Sandbox, I only have one subscription, which is the Concierge subscription, which is great because that means the Microsoft Learn Sandbox is paying for it. Under resource group, normally this would be a resource group based around whatever department or security policies I'm defining. For instance, since we're talking about an escalator function, this may be facilities or some other processes like that. In this case, I already have a resource group that's created for me, and I don't have permissions to change. So I will just have to leave that as is. For my function app name, this is where I would actually give it a name. I'll call it escalator-functions. And you'll see that it tells me this name is not available. What it is this is actually escalatorfunctions.azurewebsites.net. So it's actually creating a web page for me in order to perform these activities. And it's saying that's not available because it has to be unique. It has to be globally unique throughout the world. So what I'm going to do, I'm going to do a dash, and I'm just going to add in my initials. In theory, if this was a company such as abc.com, I would, just by adding ABC in there, would then make it somewhat unique and easily identifiable for my organization. This is where the instructions get a little bit off. If we look back at the exercise here, the instructions start getting a little off because right here we define what the resource group is, and then it starts talking about the OS and the hosting plan and the runtime stack, and so the instructions are slightly different than what we're seeing here in the web page. What we're doing is kind of scanning ahead to see what we're looking for so we can then fill in the steps here. For instance, does it say, do I want to run code or Docker? Well, it didn't actually say, so I'm going to assume code as the default. For runtime stack, further down, right there, it says to use PowerShell Core Preview. If I choose the runtime, I'll see PowerShell Core is an option. It's not the preview anymore. It's simply the PowerShell Core. For version, looks like 7.0 is the only option, which is good because that's not actually listed at all. Region, I'll leave that as Central US. All right, so next for hosting. Asks about a storage account. Now there wasn't any instructions up here about a storage account, so I will go ahead and I'll leave that as is. Here we finally get the question for an operating system, Windows versus Linux. The instructions did say Windows. That was up here on step number 7. Plan type is consumption. That was what the instructions told us. And the next. And here it talks about monitoring. Do we want application insights? And that was right there, application insights. And then it says go ahead and click create. So let's see, lastly, tags. Tags again are what you would do to help you find things at a later point, such as department IDs, billing IDs, something like that. I'm going to go ahead and leave that blank and then just say create. There you go. So it's initiating the deployment. I'll go ahead and click on my bell icon up here. Oh, I closed them all. Yeah, that will go ahead and run. So this is building out the environment for me that is allowing me to run PowerShell code in this environment. So yeah, you can see it's created a storage account. It's creating the ASP service for me. It will create a couple other items, and then it will tell me everything is finished. Let's see. Oops. Verify the function. So we should be able to find it under the resource groups. Select the resource group. And we'll be looking for the item with the lightning bolt. So you'll see that there are a couple of different things. There's a storage count here. There's the app insights with the light bulb. And then the app service with the lightning bolt. That is the one we're looking for, which will have a URL assigned to it. Still deploying. All right, deployment is complete. So I could click go to resource. I could click all resources, close that out, and then see the options right there. Don't see the lightning bolt. Sometimes it takes a few seconds for those to show up. Let's see. Resource groups. Resource group. Okay. Yeah, so sometimes the portal just takes a little while to show up, as the items take a while to show up in the portal. As we can see here in the icon, we have the lightning bolt. This is our function that we're looking at. All right, so all the way down to the bottom, we can click check our work. Yay! Now, I do know from experience, if you typo your name, for instance, I called this escalator functions, dash, and then my initials. If I call it escalator function, singular, dash, and my initials, it would fail because the name was wrong. So just because that step fails does not necessarily mean that you did not do it properly. All right, that then takes us on to the next page of the lab, and it talks about the various triggers, or the ways that we can initiate this function to run. Under triggers, let's see, we've got blob storage. So for instance, I had talked previously about HR sending me a file for new employees. Well, maybe HR creates their file and then they export from whatever HR information system they're using, goes ahead and stores that file up on an Azure blob storage. A blob, binary large object, basically anything that can be defined as a binary object. So an Excel file would be one perfect example. They store that file up there. I can then have the trigger detect that the blob was new or updated and initiate my function for me automatically. So I don't necessarily have to do it. It could just work automatically. Great thing then is because 7:45 every morning, it just goes ahead and drops those or creates those users. I'm sorry. If with a blob storage, as soon as HR drops the file up there, it runs. So maybe they have one file or two different file types to send me. One that disables users and then one that creates users. For disabling users, I can have it create or run as soon as the file is created. For creating users, we'll talk about that further down in the list here. Next one, Azure Cosmos Db. That's a database. So somebody updates a file in the database and the trigger runs. An event grid. There's various events that can happen throughout Azure, so I can have those trigger those events. I can have an HTTP request, such as an application sending an HTTP request or a web page simply redirecting a user to this HTTP website, triggering an event. Microsoft Graph events, queue storage and service bus, so some sort of a trigger via a queue or other application causing those to run. And then lastly, a timer, and that would be the 7:45 a.m. Monday morning in order to create my users. Bindings. So now that we know how to trigger these events, now we need to bind those events or bind those functions to other applications, such as my storage right here. So here we can see there's a queue trigger which talks about looking through the queue storage account in order to perform a trigger event. Same thing with a table storage account where it can trigger an event as well. So the binding is what helps you tie into those various triggers as opposed to just the triggers themselves. All right, when you go to create the functions in Azure, there are some quick start templates. Very helpful. Sometimes they are just simply hello world type activities, but they're still fairly helpful for getting the ball rolling. If those don't work for you, there are custom templates that you can create, and you can even go as far as creating these in Visual Studio or other applications. Navigating to various files. Now there are I will actually use this window right here to show that there's a couple of options in order to see things in your environment. The first off is oftentimes you will see some things over here on the right, and so you have to actually click a button somewhere in order to have that menu fly out. Additionally, there are items down here such as the logs, events, and console, and you click those buttons in order to cause it to fly up. We will be using these, and they are a little confusing when the instructions talk about them, and not just because the instructions are a little old. Now, we'll walk through those and we'll highlight them as we see them. Main thing at this point is to pay attention to the fact that they're there. Testing the function, there's a couple of different ways to test it. One is to use an application such as Postman or the curl application from the command line. These are ways that we oftentimes that can be used to manually test triggering of web-based APIs. Additionally, you can test this directly within the Azure Portal. This may not necessarily be as quick or as legitimate as using the Postman or curl functions, but they are still pretty helpful and they're built right in. And then there's also a monitoring dashboard, which we can see right there, monitoring on the left-hand side, and then we can see the run processes on the right-hand side. For instance, this last run at 16:32 and 48 seconds had a result code of 200, which is a success, and took a total of 2.5 milliseconds in order to run. Along with that, there's also a log window, a streaming log window, which you will see down at the bottom of the screen when we get in there, along with the errors and the warnings. All right, let's talk about creating our first function. What we're going to be doing, again, this is an escalator company, and we are wanting to monitor the temperature on our devices. What we're going to do is we're going to be getting some temperature information from our IoT devices, and we want to do one of three things. If the temperature is between 0 and 25 degrees Celsius, we're going to say everything's okay. 25 is a little warm for us humans, but for mechanical equipment, not so much. If we're getting 26 to 50, we should be getting a caution alert. Yeah, something might be wrong. It might be normal, but pay attention. And then lastly, anything above 50 should give a danger. If you were to think about this as a stoplight, this would be red, yellow, and green. All right. So let's go ahead and add a function to our app. Now these steps are a little bit out of date. Again, the Azure Portal has changed, so let's see what we can do. Come on back to our portal here. First thing on the left-hand side, I'm going to come down here to where it says Functions, and I'm going to click Functions. We can see here there are currently no functions listed, so I want to add. Asks me what type of trigger I want, and in this case, I'm going to be doing an HTTP trigger. The idea being that there is some sort of a management tool or a monitoring tool that's on the escalator in the remote site. Every 5, 10, 15 minutes, whatever it is, that tool is going to be sending me an HTTP request with, or HTTP post, with some information in it. And so when that post comes, I want to perform the function based off of the activity that I'm getting. So I'll choose HTTP trigger. And then for the name, I will call this drive gear temperature service. There we go. I've been here before. I've typed this before. And then create a function. So this will create one function in this list. It should show up here shortly. Oh, let me go back there. We can see there's my service. I can add additional services here if I want. So I can have multiple functions, multiple functions all within the same function app, and each one doing a slightly different task. All right. So we'll go ahead here, and now I want to edit this. The instructions are completely wrong here. Completely wrong for the updated UI. What I want to choose the code and test option. Let's see. That was creating it. And then talks about code and test. And we want to edit the run.ps1 file. And we want to paste all of this data in it. So I'll go ahead and click copy. Come back, I can see that this is now run.ps1. If I click on the drop down, see I have a function option as well. I want the PS1 for right now. Go ahead and select all that data and delete it. My first thought is I want to right click and paste, but there is no right click paste. Instead, for my keyboard, I'll hit Control V to paste it all in. All right, very briefly, what's going to happen here is it loads in some PowerShell code or some PowerShell components. It then sets up a parameter. Okay. It writes out to the screen saying, hey, this is an HTTP triggered function request. Okay. Let's see. It looks at the data that it gets. It pulls out a name and it sets a variable called, there we go, So that's a variable called $name. Let's see, it does a little bit more research. Is this, yeah, if I have a name and I have an HTTP code of OK, then I'm going to go ahead and I'm going to save a variable called body, and it just says hello name. So if I send it a name Joe, it should respond back hello Joe. Otherwise, it's going to say, hey, give me some information. You're telling me, you're not telling me what I want to hear. When it's all done, it's going to go ahead and send back a status code of OK, and it's going to send back the body of hello Joe, hopefully. I'll say save, and we'll see the logs pop up down below, which will show that it is in fact uploading. All right. I'll hide those logs. I don't necessarily need to see those. So that was run.ps1. The instructions then tell me, if I keep scrolling on down, that we want to edit function.js. Again, the instructions are a little out of date, but what we want to do is we want to take this data right here and we want to paste it in function.js. So I'll go ahead and copy that, come back to the drive gear temperature, and right here I'll click the drop down and choose function. All right, go ahead and delete all of that and Control V for paste. And then lastly, save. All right, so while that log is going, lots of information there. Let's look back at the instructions. Now we get to test the function. There's a couple of different ways we can test this function. Like I was saying before, one is with the curl command line utility. This is built into Windows 10. This is built into Linux and Mac OS. Pretty much all operating systems nowadays have a curl utility available via the command line. If yours doesn't, yeah, you can come over here and you can download it. It does make notice here that we should make sure we're not using not trying to use curl in PowerShell. The version inside PowerShell is slightly different than the version from the command line. All right, so we need to get a couple of pieces of information and then tie them together. The first one is we need to get the function URL. So if I come back to the function, I can go ahead and hide the logs. And click Get Function URL. And copy to clipboard. Then I'm going to open up a notepad. Just going to paste it right there. Very briefly, if we look through here, we'll see, first off, HTTPS. So it is fully encrypted. It goes to my site, escalatorfunctions-ecg.azurewebsites.net. -API and then drive gear temperature service. Along with that, it does actually send in a code which we'll be deleting. We'll be removing that in just a minute. All right, so that's one piece of information. We'll need 2 more. Next one is the securing of the HTTP triggers. Not only is this SSL is a site SSL managed, but it also has a key that's associated with it that we want to control, or that we need access to in order to test this for. So what we want to do is we want to go back up to the manage section and we want to find the default function key. All right, go back up here and, oh, actually right there, function keys. Isn't that handy? Right there's my default. It says, hey, this is hidden. Click right here to see it. It's good practice to hide that, just so nobody else can copy it by accident. Right there, copy to clipboard. Coming back to my notepad, and I'm going to paste that in. As you can see, this key that I just copied is exactly the same as that, but we're going to be putting them in slightly different areas, so we want to do them differently. All right, and then lastly, it tells us, hey, we're going to use the curl command from the command line, and we're going to run this right here, but we're going to change some of that. So I'm going to copy that and then come back to my notepad right here. All right, so here's the curl command we want to run. And as we look through here, I can see right here, it's asking me for my function key. Again, the less than, greater than brackets help identify something that needs to be replaced. So that's telling me you need to replace this with the key for your function, which is this right here. So I'm going to go ahead and copy that. And I'm going to paste it right here, replacing the less than, greater than at the same time. There we go. So it's going to run curl, curl. It's going to send some header information specifically saying, hey, I'm sending you some JSON data. More header information basically saying, hey, here's the key. Here's my authorization to be able to come in here. It's going to send this as a post type data, post as opposed to get. The data it's going to send is, here's a name. My name is Azure Functions. And then where do we send it to? I'm going to come up here and I'm actually going to copy all of this. So everything before the question mark. And the reason why I'm copying that, copying the whole thing as opposed to just this portion here to replace what's in my brackets, is because I'm not entirely convinced I spelled that right. That's just the kind of guy I am. So I'm going to copy that, paste that. Very briefly, this is all wrapped around. That's because I have word wrap. So what this will look like right there. It's all one big long line. All right, so let me copy that. And now I'm going to open up a command prompt. Now, if everything is working perfectly, I will just be able to right click and hit enter. And this curl command will simulate a device going up into Azure and trying to execute my service function, my serverless function, utilizing my security key up on this remote site. In this case, this is mostly just test code. When we looked at the code itself, right there, hello Azure Functions. So it just simply returned back hello with the name I sent it. If I hit up arrow and I come back here and I change the Azure function, this text right here, to anything else, then it just simply should return back hello Ed. This may not always be super quick. It's just the way it works because we are running through the cloud. But in this case, it just happened to work fairly well. There's our warning. Yeah, don't run this through PowerShell. The PowerShell curl command is actually a reference to the invoke web request, which is not the same. We can also use this using the test command in Azure. So if we come back up here, back into Azure, we'll go back to our code. There is the test command right here. And we can come in here and we can start specifying headers. No, actually, hold on. I don't want to do that. I want to replace the body. Test user. There we go. In theory, this is the new name, or this is replacing the name that I had sent from the command line. And so now if I run it, it should hopefully not time out on me. And on the output tab up here, I should see an output of hello test user. There we go. With a response of 200 OK. Yay! All right. So that worked, quite to my surprise. Last couple of times I tried that, it simply timed out. But that's the way things happen on the cloud, especially in a test environment that you're not entirely sure is going to work properly. Go ahead and hide those logs. While we're here, let's look at the monitor tab here. And we'll see, should see, maybe not. I was expecting to see runs. Okay. All right, so now we come down to adding business logic. So back to the scenario we were talking about of running our escalator business. This right here, this JSON data, is an example of the data we'll be receiving from our Internet of Things device. We'll see here, there's a readings section. Inside of the readings section, we'll see, hey, here's drive gear ID number 1. We'll get a timestamp along with that, and then the associated temperature. All right, so we're getting the temperature for drive gear number 1. That's perfect. We'll then get more information, in this case, drive gear number 3, another timestamp, and a temperature of 45. As you can see here, the temperature of 45 is above what our scope for good was. That means that should give us a warning. We'll get another drive gear with another temperature. In this case, we're getting 3, but we could be getting 100 different readings all at the same time, all from the same command, or we could just be getting 1. And it will all be stored in a JSON data file following this data format. All right, so if that's what we're getting, here's the code in order to parse that. So let's go ahead and copy that. Let's go back to our run.ps1, and replace that. So we're replacing our essentially hello world code with some real world code that we'll be running. Very briefly, let's run through this. All right, so we're using the system.net namespace. Perfect. We're going to get a request and a trigger metadata, whoever's triggering us. We'll write out to the screen, hey, we were triggered. We're doing something. This will be mostly for logs. We then store those readings. All right, all the readings that we were just seeing in the diagram. Readings right there. And then for each reading in reading, so we're going to loop through them. So it doesn't matter whether we've got 1 reading or 100. We're just going to cycle through them one at a time. If it's less than 25, okay. If it's less than 50, caution. Otherwise, the third option, if it's not okay, if it's not caution, then it will simply spit out danger. When it's all done, it will go ahead and write out to the screen, yeah, okay, here's your status. And then go ahead and return back the readings. Yeah. Otherwise, if something bad happened, go ahead and say back, hey, you sent me some bad information. And then here is your response. All right, so that's what we're looking for. Let's go ahead and save that. And now we want to run it. Now to run it, we could again do this through curl, through the curl command. We could come back here to our command line, and where we have the post data right here, we go ahead and replace that with our sample JSON data. That would get a little ugly from the command line. So we're actually going to use the Microsoft tools in order to help us here. First off, let's hide those logs, and let's come up to the test and run option. Yeah. All right, so we go up to the test and run option, and we're going to copy the sample readings data over here, and we're going to replace our body with our sample data, and then go ahead and click run. Now again, fingers crossed that this will work. Again, it's a test environment. I may have broken something. There we go. Okay, so we now have a status of okay, temperature 23, drive gear number 1. So it was able to loop through that data and see, yes, the very first drive gear you sent me, it had a temperature of 23, which is okay. Perfect. Drive gear number 3, temperature of 45, which is a caution, and then same for the third gear, which is number 18, with a value of danger. Danger, Will Robinson, danger. Yeah. So that was the scenario. We look at the input here. This is the code that we're receiving back from our IoT device. We then have a serverless function that's running up in Azure that simply receives the data, parses through it and does some business logic. In this case, the business logic was simply to write back out saying, yes, that's good, no, that's not. That business logic could have also been text somebody, email somebody, shut down services in its response. There could have been a lot of responses happening there, especially for that critical system or the critical gear. Maybe you wanted to slow down the process. Maybe you should have just triggered back, shut down service. So there was a lot of tasks, a lot of capabilities we could have done there. And then lastly, let's see, is our monitor working? There we go. It just took a while for it to show up. We see your very first response, which was from the command line on my machine. Result of 200. 200 is the HTTP OK. We can see the duration was fairly long. The very first time you're doing this, you're actually compiling the code. So the first process can actually take quite a while. And that was the one where it just simply responded back, hello. Second run here, we see, well, that took about 87 milliseconds. That was the sampled test that we did through the web page here for the test. And then the last one was the one we just ran where we actually sent it some temperature values. Again, the milliseconds were fairly high because we had just replaced some of the code, and therefore it took a while for it to run. All right, and then summary. Check our knowledge. Which of the following best defines serverless logic? Code you write that doesn't run on servers, code you write that runs on servers you manage, or code you write that runs on servers cloud provider manages? That would be the cloud provider. The container that groups functions into a logical unit for easier management, deployment, and sharing is a function app. Function app, is that right? Function app, there we go. And then we secured our function against unknown HTTP callers by requiring a specific API key. Yay! Which of the following fields in the name header of the HTTP request contains this key? For that, I'm going to come back to my command line. And that was the header X functions key. So X functions key, and check your answers. Yay! All right, so there you go. That's how we would do a serverless logic on the Azure Web Services.